Okay, so here we are on the third piece of the endocrine system lecture. We're moving on to the thyroid and the parathyroid glands. We've already talked about the hypothalamus, both pituitary glands, and the adrenal gland. So let's move on to the thyroid and the parathyroid. So first of all, where is it? So it's going to be located, what it does is it sort of straddles your trachea, which is your windpipe right here, and it's going to straddle it. So you have two lobes, one on each side. And so that would be the thyroid gland. And the thyroid gland, it secretes a couple of different hormones. The first one is called thyroxine, and that's going to help set your BMR. So what does BMR stand for? Basal metabolic rate. Okay, so what it really means is your metabolism at rest. So basal as in like baseline, at rest. Okay, so basal metabolic rate, baseline at rest. Okay, so what's happening in your body at, when you're just relaxing. Okay, so let's talk about the thyroid a little bit. So in the thyroid, if you were to look inside the thyroid, it's organized into these circular structures. Circular structures are often called follicles. So here is your follicle. And surrounding that follicle are these square cells. Those are called follicular cells because they make up the edge of the follicles. And those are the ones that secrete thyroxine. And the thyroxine, that is the one that is going to set your basal metabolic rate. One thing that I need you to know is that thyroxine is lipid soluble. So that means that the receptors inside, it doesn't require a second messenger, and it can alter your gene expression. And that's why thyroxine can have a pretty significant effect on the body. So it's going to be stored inside. And part of the process of making thyroxine is the incorporation of iodine. You'll need to know that for later. So it takes the iodine, creates it, and then you create thyroxine. Okay, so by the way, sometimes textbooks refer to thyroxine as T4. I prefer to just use the word thyroxine, so you should be familiar with thyroxine. Okay, now in between the follicles, okay, so here's a circular structure. So down in here as well as over here, in between the follicles, you have cells that are called parafollicular cells. Para sort of means like next to, so parafollicular cells, and they secrete a different hormone. That hormone is called calcitonin. Now, based on the name, what do you think it regulates? Calcium, right? So the calcitonin is going to regulate calcium levels, and it's going to work against or opposing or antagonistically against the parathyroid hormone. Okay, so we got thyroxine setting your basal metabolic rate, and we've got calcitonin. Let's talk about regulation of thyroxine. It is a negative feedback loop. It has a tropic hormone in it, just like we've already seen. So I do want to go through it as well, because I might ask you specifically about this negative feedback loop. So here is the hypothalamus. Remember, the story usually starts with the hypothalamus because it's the one that controls the master, which is the anterior pituitary. So the hypothalamus is going to secrete thyrotropin releasing hormone, TRH. Again, when you see TRH, that stands for releasing hormone. So the thyrotropin releasing hormone means it comes from the thalamus, and it causes the release of a tropic hormone. In this case, the tropic hormone is going to be called thyroid stimulating hormone. And based on what it does, what do you think? Based on the name, what do you think it does? It stimulates the thyroid, and it's going to stimulate the thyroid to produce the hormone thyroxine. Okay, so that thyroxine is then going to go increase basal metabolic rate. That's the primary action. But what it also does is help to regulate its own self levels. And what it does is it participates in the negative feedback, which means that it goes back and it inhibits the things that stimulated it in the first place. Okay, so the thyroxine is going to inhibit both the anterior pituitary, preventing it from secreting thyroid stimulating hormone, as well as the hypothalamus, preventing it from secreting the thyrotropin releasing hormone. Okay, so the net result would be to reduce the levels. So again, this is a dynamic loop. We're not talking about yes thyroxine or no thyroxine. What we're talking about is regulating the levels of that thyroxine, right? So it's constantly going to be in flux, up and down just a little bit, so that when you get too much thyroxine, you're going to increase the inhibition, and when you increase the inhibition, that's going to decrease the levels back down. And when it becomes too little, that'll reduce the inhibition. Less inhibition means that the levels are going to go back up. So it really is the dynamic constant flux of more thyroxine, less thyroxine, just moving around, but never going too far in one direction. Okay, so the point of the negative feedback loop is to keep the levels of thyroxine fairly consistent within range. Okay, so now let's talk about what happens when the loop goes awry. Okay, so when something disrupts the negative feedback loop, what happens? So this is going to happen when you don't have iodine. So if you're not getting enough iodine in your diet, remember that the iodine is used in the structure of making the thyroxine. So if you don't have iodine, you cannot make the thyroxine. Okay, so not enough iodine means that you can't make thyroxine. That means that you'll have very low levels of thyroxine. So that would have effects on the basal metabolic rate and the growth of structures. But the other thing that can happen is because you don't have enough thyroxine, that makes it so that you've lost your negative inhibition. Okay, so if you're losing your negative inhibition, that means that you're going to be increasing the hormones that are upstream of the thyroxine. So what's going to happen to the levels of thyrotropin releasing hormone? They're going to go up because you've lost the negative inhibition. You're also going to lose the negative inhibition of the anterior pituitary. So now what's going to happen to the levels of the thyroid stimulating hormone? They're also going to go up. Now, thyroid stimulating hormone is not just a tropic hormone, which means that it's going to stimulate the thyroxine. It's also a trophic hormone, which is a pH, trophic hormone. And what a trophic hormone means that it causes the gland that it goes to grow, to get bigger. Okay, so what that's going to do is because you don't have enough of the thyroxine, because you can't make it, you're going to lose the negative inhibition. So this goes away. The levels of the thyroid stimulating hormone are going to increase, and that's going to continue to try to stimulate the thyroid. And what it's going to do is going to make the thyroid grow. Okay, so you're going to end up with an enlarged thyroid. Now, what is an enlarged thyroid called? You get this big old lump in your face, and that's called a goiter. Okay, so that is a goiter. And the goiter comes from that lack of iodine, which means you can't make the thyroxine, so your levels of thyroid stimulating hormone are too big. So the point of this is to understand how this negative feedback loop is a very, very careful balance, and if you lose one piece of that balance, it's going to throw off the entire system. Okay, so what might be the fix for something like this? Okay, so you might need to go in and do some surgery to remove the mass, but the way to really just fix this is to give them iodine supplements. Once you have the iodine, that means that you're able to make the thyroxine, and that's going to reestablish the negative feedback loop and go back to normal. Okay, so I really suggest that you take a moment, pause this, and see if you can diagram out the relationship. Think about which hormones stimulate which hormones inhibit which hormones, and how do you keep the thyroxine levels fairly consistent. You also will need to go ahead and start learning which glands secrete which hormones, okay, and what are their actions for those. Okay, so take a minute and try to diagram this out, make sure that's comfortable for you. Okay, on to the parathyroid glands. So para, next to, embedded in. Okay, so the parathyroid glands are these little pink structures right here. They're not actually pink, they're just on this diagram. Little pink, little circles here that are embedded inside the thyroid gland. Okay, so it's called the parathyroid gland because it's embedded inside of the thyroid gland. And the hormone that is secreted by the parathyroid gland is called PTH, which stands for parathyroid hormone, and it works in conjunction with the calcitonin, which is secreted from the thyroid to regulate calcium levels. So this is, remember, this was the example of the antagonistic loop that I talked about before, but now it's not just enough to understand what an antagonistic loop is. Now I want you to focus on the specific interactions and actions of both calcitonin and parathyroid hormone. Okay, so an antagonistic loop is another example of a negative feedback loop. Okay, so it is a negative feedback loop because the purpose of it is to maintain a consistent level of that calcium level, of the calcium in the blood. Okay, so this would be an example of what's called humoral stimulation because the secretion of both the calcitonin and the parathyroid hormone doesn't require another endocrine gland, it doesn't require neural input, it's just directly monitoring the calcium levels themselves. So the stimulation of the calcitonin is the decrease of the blood calcium levels. It doesn't require any input from the nervous system at all. Okay, so here's the calcitonin. The calcitonin, again, is secreted from the thyroid gland, and it will be secreted from the thyroid gland when the levels of, when the levels of the calcium become too high. Okay, so when the levels of the calcium become too high, that's going to cause the calcitonin to be secreted from the thyroid gland. And what it then does is it takes the calcium out of the blood and puts it somewhere. Where do you think it puts it? Calcium is going to be stored in the bones. One of the functions of the skeletal system is act as a reservoir, like a bank, for extra calcium. So it'll activate those osteocytes that'll then take the calcium, put it into the bones to store it in there. When you take calcium out of the blood and put it into the bones, that means that the blood calcium levels will decrease. You can also secrete the calcium out through the urine. So you'll now have less calcium in the urine. And this is a dynamic loop. So if this goes a little bit too far and the blood calcium levels fall too low, that'll then cause the parathyroid to release parathyroid hormone. Okay, so again, humoral stimulation, no neural or endocrine input elsewhere. And the parathyroid hormone, what it's going to do is it's going to increase the blood calcium levels back up, and it does this by activating what are called osteoblasts with a B. And that takes the calcium out of the bones, puts it back into the blood, and that'll increase it. It also will cause more of the calcium to be reabsorbed from in the kidneys so that it comes back into the body, back into the blood. That's going to increase the blood calcium levels back up. When they increase it back up, that's going to continue to, balance it out. If it goes a little bit too high, then you release the calcitonin, and it just continues in a dynamic circular loop. But the end result is that the blood calcium levels may remain within a very specific narrow range. Okay, so this is how you maintain calcium homeostasis. Okay, so main points here. Make sure you understand, you do need to know the specific hormones. You do need to know what glands secrete them. And you do need to understand how they oppose each other to make sure that the blood calcium levels remain the same. So you need to know the action of each. Calcitonin is secreted when the blood calcium levels get too high, and its action is to decrease the calcium levels. Parathyroid is secreted when the blood calcium levels are too low, and its function is to increase it, right? So one goes down, one goes up. Okay, that's enough for now. I'll do one last piece with the pancreas and some miscellaneous things.